Alright, question about a normal distribution. So we're not going to mess around with this. The journey time, so journey time is on the x-axis. Let's go ahead and draw a little graph. Journey time here. Let me just get rid of that. I think I'll have a pen instead. Yeah, okay then, so here's journey time on the x-axis. So I'm going to call this t for time. And it follows a normal distribution, so I'm going to draw just a rough shape of a normal distribution. We're going to put a little dashed line where the mean is, and I think we'll highlight the mean is 37 and the standard deviation is 11. So mean is 37, and look, we'll just make a little note here, standard deviation is 11. Okay, so here's part A, and we might like to draw a diagram for all parts. Find the probability that at a random workday, Chloe's journey time is between 30 and 40 minutes. Okay, so 40 is about here, 30 is about here, and we want to know the probability. Now probability is the area here, and of course we're going to reach for norm CDF on the calculator. So let's go and do that now. We are in menu, probability, distributions, and you can see norm CDF. We're never going to use norm PDF, norm CDF and inverse norm, and it tells us what to put in here, right? 30 is the lower limit, we've got the picture there to help us, 40, and it's nice that you have all the numbers, the mean, mu, 37, and that little sigma, standard deviation. There we go, so let's write that down, and we will say that we can just write the answer to 3 sig fig, 0.345. If you want to be fancy, you can say the probability that the time is between 30 and 40 minutes. You can just put these little inequalities. If you want to be fancy, you can do this. But you don't need to. It's perfectly acceptable just to have this highlighted. Alright, so let's have a look at B. Chloe leaves home at 8:10 on a work day. So she leaves at 8:10 and she journeys to work. Okay, work starts at 9 o'clock, and B is what's the probability that Chloe will be late. Well, you can see that, look, the journey time here, if it takes more than 50 minutes, right, if the journey time takes more than 50 minutes, if t is greater than 50 minutes, then she's late for work. So we're going to draw the picture again. Here's journey time. The journey time in terms of the distribution has not changed. This is still 37. This sigma is still 11. And we want to know how many times is Chloe actually going to take up. Let's just go back. How many times is Chloe, or what's the probability Chloe will take more than 50 minutes for her journey, because then she'll be late. So we're actually looking for the probability of t greater than 50. So now we've reached the calculator again, right? And we can just go up, up, return, and the lower bound is now 50. Upper bound, yeah, you've been taught just to put in a very, very big number. I'm going to put 50,000 in, 3711, boom. So the actual probabilities will be more than 50 minutes for the journey, which means she'll be late, 0.119. Give that a little underline. Underline the previous one. Perfect. Okay, now the last one I think is the hardest one. Let's take our time with it. Chloe wants a probability that she's late for work to be less than 5%. Less than 5%. Well, I think we're going to have to connect part C with part B that we've just done, right? Here's part C. Let me just get that off. Boom. Just relearning how to use an iPad. So here's part C. Now, I think the trick is to have a little look at this. Now, what did we find there? We found that if the journey time 50 minutes or more, this would definitely be late, right? So we found this journey time here was 0.119. 11.9% of the time the journey takes 50 minutes or more. So So what we're trying to do is we're trying to reduce this figure here down to 5%. Okay, so up we go here. Let's have a little look. This is 37 again. This is 11. There's a certain value k, and we want this to be only 5%. So you can maybe see where this is going. This is going to be an inv norm, and an inverse norm we need to put in the area of the probability first, and then out will come this k value, and this will tell you the journey time. So let's go ahead and find that. Menu, probability, distributions, inverse norm, right, 0.95 first. Mean again is 37. Standard deviation is still 11. And that is 55.1. So we're not quite finished yet. We've got k equals 55.1. Now what does that mean? Well, it means that Chloe has to allow herself at least 55.1 minutes to get to work, because then that will ensure that only 5% of the time, right, she'll take longer than 55 minutes. So the magic last step, of course, is that if work starts at 9 o'clock, we have to subtract the 55.1 minutes. So Chloe has to set off approximately 8:05, right? There we go.